Last turn, we have seen the concept of bibliometrics, how it has developed. Also, we have seen what are the applications of bibliometric techniques in the measurement of behavior of information. Then we have discussed the phenomena of scattering and seepage. Especially in scattering, you have noted that how the information gets scattered on a given topic in the related journals in such a way that on any given topic, remember the topics which were studied by Bradford himself, the lubrication and geophysics, okay, the bibliographies which he studied. And then in the two bibliographies, he arranged the journals in the order of decreasing productivity, meaning thereby that the journal which has published maximum number of articles in that bibliography for that particular period will come first, and then successively according to the decreasing productivity. On the basis of that, he was able to formulate Bradford's law of scattering, that on any given subject, on any given topic, the information gets scattered in the related journals. Am I right? And then we have also proved the Bradford's law by the equation and by the data collected, that too by our own students. And you see that the results are almost accurate as per Bradford's equation. 1:a is to a square, right? While 1 represents the total number of journals in the core area, in the core zone, which is called nuclear zone, and A represents the number of journals in the successive zone, in the next zone, that is zone 1. Similarly, in zone 2, it will be a square. 1:a is to a square. And you know what is the value of a, and the value of a is the value of that is equivalent to 1 in the nuclear zone. How many journals have been, collected to form a core zone, which give the maximum number of articles. So here in this example, it was 11 number of journals, right? So in the next zone, you are looking for 11 into 11. And similarly, in the next zone, you are looking for 11 into 11 into 11. Like that, it will go, and this is the equation of Bradford. But there was one problem with regard to the concept of scattering which has been given by the Bradford. The concept is, if you put it in a simple graph, you see, this is x-axis consisting of number of journals, but the values are not the pure numbers, but the values are converted by the log table. Okay, so cumulative number of journals right from that 0 to x1 is the number of journals in the first zone, x2 the number of journals in the that is the previous zone, and this one is the first zone, and 718 is the third zone. Okay, cumulative number of journals, this is log n, and here on x-axis we have the value 10 is equal to 500, then 1000, then 1500, 2000, 2500 and so on. And when you look for those points which have been given in the table, how many journals? In the how many journals? 1346. Okay. And this one, it is 200.
600.
No?
1,300.
Yeah. And then this 4002. The value is not very far. Okay. And that way, this graph will become a straight line graph. हो सकता है नीचे ऊपर थोड़े से points आएंगे, but difference is not much. If you put the exact log value, so maybe it will come here or maybe it will come here. But it is almost a straight line graph, which proves Bradford law of scattering. What? That this is the nucleus showing a sharp rise of journals, and then the number of journals will go on increasing, and almost according to the same equation, A is to A square is to A cube. This is a straight line graph. This is exactly according to what the theory has been given by Bradford in his equation, Bradford's law of scattering. Bas samajh mein aaya okay? You understand? Only there are two things. First is, if you draw a simple graph, then you get the hyperbolic graph, which does not explain Bradford's law. Because Bradford's law is different. Bradford's law is this, that the number of journals should go on increasing. For the same number of articles, the number of journals should go on increasing. You know? This will come when you convert into log values, both the values. You will do it with your own data, and then you will be able to draw the line, and you will find you will come close to it. This is the data collected manually. Now you will be collecting data through computer, Web of Science. So you are supposed to be more accurate. Manually you might have missed a few references, a few journals. But when you are using Web of Science, you cannot afford to miss. So supposedly your graph will become a straight line graph. Here also it is a straight line graph, but maybe some point is here, some point is there. Similarly, some point is here, some point is there. So when you draw a line, it becomes a straight line graph, which explains Bradford's law of scattering. Is that clear? Then, lastly, what are the applications of Bradford's law in the library? Looks like a more theoretical exposition, nothing to do with the practical aspect of language. But it is not like this. Do you understand? For example, I give you the example, practical example of a library. Suppose you are librarian of what? Of a special library dealing with a particular subject, dealing with a specific subject. You have a limited budget. What do you like? You like that your budget must be spent judiciously. You cannot afford to waste. Of course, you get suggestions from whom? From the scientists. That procure this journal, procure that journal, and all that. But what they are telling, they are saying it by their own experience. And the experience varies from one scientist to another scientist because the subject of research or the area of research varies. You might be doing on some topic, he might be doing on some other topic, but both the topics are related. He might be knowing his own periodicals in his own field. She might be knowing her own periodicals in her own field. So it is only by experience you are saying, you are recommending that these titles should be procured. But if you apply here Bradford's law and prepare sort of this data and find out what are the core journals. What are the core journals in that area? And by this type of study, you will be able to convince the scientists that in their area, these are the journals which are the most productive journals. Therefore, whatever budget they have, it should be judiciously spent in the procurement of those titles only which belong to the core area. Am I right? So the first application of Bradford's law is that it affects the acquisition policy of the library. Of course, in a general library, like a university library, this type of study may not be possible because there are so many different subjects. But in a special libraries, this type of study is naturally can be conducted almost every year or almost every after a few years, and you can concentrate upon the core journals while you are procuring the journals for that special library. Is it right? Then secondly, first point is the acquisition policy. इसको बंद करो. It has two aspects. One aspect was the theory of Bradford's law. And second aspect is the graphic representation of Bradford's law. The theory which Bradford has given, on the basis of which he formulated the law of scattering, if you put that data in the simple graph, all of you must have done, in mathematics graph, you take one thing on x-axis and y-axis. If you take here the number of journals, if you take here the number of articles, then naturally you find that you divide into a figure of 10. You say that this much represent this much number of journals, this much represents this much number of journals, and so on. That is how you prepare a graph. So if you prepare a simple graph, The simple graph would mean that the journals which are coming first, the journals which are most productive, they will have most number of articles. And this will have less number of articles. We are not putting into the equation. This will have still less number of articles. This will have still less number of articles. Like this. Am I right? Simple Bradford's equation. Simple representation of Bradford's law by a simple graph, the ordinary graph. And you find if you join these points, it becomes a hyperbolic graph. A graph which represents what? Decreasing number of journals. Whereas Bradford's law talks about increasing number of journals. That is the sort of anomaly between the theoretical representation of Bradford's law and graphical representation of Bradford's law. Do you understand my point? If you are putting this data in a simple graph, the graph will come as a hyperbolic graph, meaning thereby that the number of journals is going on decreasing. Just a post. And Bradford's law says that it will multiply. That's why there is A is to A square is to A cube is to A4. You understand? So this work or this anomaly was studied by B.C. Vickery and Brooks. And what did they do? They said that Bradford in fact gave two laws. One was what he gave in theory. But the graphical representation of this theory is not in the same way as we interpret by a simple graph. Rather, what we have to do, we have to put it in a log form. We have to use logarithm table. The values. Now, इसको डाउन कीजिए. Yes, we were discussing the applications of Bradford's law. And we have seen the first application is the acquisition policy. Of journals in a given subject, which is true in a special library. Is it right? Applications of Bradford law. The first application is that applying Bradford's law, you can have a definite acquisition policy, wherein by conducting study, you can find out what are the core journals and use your resources accordingly. Second thing may be that you may be helping the specialists with regard to a number of things. Like, you can inform the specialists about the country which is most productive. about the language which is most productive, meaning thereby in which most of the literature is coming up. Maybe they might be knowing, but they may not be knowing fully what percentage of literature is being published in which language. You understand the point? Not only the most productive language is important, others are also important. You are giving them information that these are the languages in which the literature on their subject is being published. Most productive language is this, number 1, number 2, number 3, and so on. Maybe some language at number 5 or 6 may be important for somebody. So you are serving the specialists with regard to this point, with regard to what else? You can tell them the institutions which are most productive. You can tell them the names of the scientists who have been most productive. You know, if you are a scientist, you might be having some idea who is writing more, but they may not be having exact idea that who is really on top and has remained on top from which period to which period. It is the librarian or documentation officer or information scientist who will be conducting this type of study and will be informing the scientists from time to time. Is it so? There may be some other aspects also when you will be studying the applications or doing yourself the application of bibliometric laws. Then the third important thing is Bradford law can help in judging the completeness of a bibliography. Completeness of a bibliography. Can you tell me how? Can anybody tell me how? How can somebody judge that the bibliography is complete? You know completeness? What is the meaning of completeness? Completeness means that you have done justice in the collection of information from all different sources. You have not left out some sources. You have not picked up some special sources and left out others, thinking that who cares. But in our field, who cares is a very, very bad word. You are not doing justice with yourself, with your profession. You are not doing justice with the people whom you are serving. You understand? You see, if you want to judge that a bibliography has been honestly compiled, keeping in view different sources of information on that subject, on that topic. For example, on lubrication, which he was studying, Bradford. If bibliography is complete, then naturally, when you are plotting a graph like this, it should be a straight line graph. Okay? But if you are judging the completeness of a bibliography, and if you find that here you are putting journals, here you are putting articles, it goes up and after some time it goes down. The graph is drooping. Graph is drooping. What does that mean? If the bibliography is complete, the graph should go up. Am I right? The graph should go up, it should be a straight line graph according to the Bradford's law. But after going a midway, it drops. It means number of journals which were to be consulted, you have not consulted. That is why the sources, the journals, the number is not there. That is why graph is coming down. In a bibliography, comprehensiveness is most important. You understand me? For example, if you are sitting in the library on a reference desk, somebody comes to you and asks you what the library has or what is available on any given topic. For example, the given topic may be library classification, maybe faceted classification, maybe automation, maybe OPEC. And the job was entrusted to you. And you said, okay, whatever is available in our library, I will find out, prepare a list, give it to you. And what is available elsewhere, that too I can find out. I have the technology available. And then I will prepare a list, give it to you. What does it mean? You have taken a big responsibility. You have to inform him comprehensively what is available. You cannot pick and choose. You cannot shirk your own responsibility. So just compilation of bibliography is not important. When you take the responsibility of compilation of a bibliography, it has got to be a comprehensive bibliography for the period which you have mentioned. It may be 2 years, it may be 5 years, but the period should be there and the bibliography should be complete. That is why you can judge the completeness of a bibliography by applying Bradford's equation, by arranging them in a decreasing productivity and then putting them on a graph and find out whether it is a drooping graph or it is a straight line graph. Alright? So that is about the completeness of the bibliography. Then another very important study which is somehow related to Bradford's law is the Pareto's 80-20 law. Alberto Pareto was an Italian. He was an economist. And he gave his very famous law which is called Pareto law. You will appreciate it's very simple, but it's very important even today. What this law says that 80%, he was an economist, he said 80% of the country's wealth is in the hands of 20% people. 80% wealth of a country is controlled by 20% of people. This is true. This is called 80-20 law of Pareto. What do you think of a library? What percentage of collection in a library fulfills 80% demands of the users? You have gone to this library, you have seen the big stacks. What do you think? That every book is going to be used every time, every day, even in a month, even in 6 months? What is the percentage of demand? And what is the percentage of collection that is met out? You understand? Here also, this is applicable. That 80% demands of library users are fulfilled, or in other words, are concentrated on 20% of the whole collection. Is that so? This is according to Pareto law. The same is applicable in library also. Take another example. You must be having a car. If not, you must be having a two-wheeler. For the servicing of the car, you go to a standard shop or garage. Have you been to this Maruti show? No? कौन सी है? क्या कहलाता है? GT रोड क्या कहलाता है?
देव मोटर्स.
हाँ?
GT रोड.
हाँ, देव मोटर्स. If you have not gone there, go there. Just have a look. You see, when you go there, they have all parts of all models of Maruti car. Standard. Spare parts. Warehouse. Do you think it's a small job? It's like a library. There may be small parts, there will be big parts. All different models. It has got a big space, big shelves, and everything is numbered and entered in the computer. When you go to that person who is holding the store, charge of the store, he will first of all check on the computer whether for this model this thing is available or not. And then each and everything he will tell you. This is the cost, this is this is this. Right? Then also, this 80-20 law is applicable. Because 80% of wear and tear is concentrated upon 20% parts of the vehicle. Isn't it? So this much is clear. That Pareto law, which was given in the field of economics, holds true in the library as well as in the warehouses. But this 80-20 law is somehow related, akin to Bradford's law of scattering. This was shown by none other than Eugene Garfield. He collected a data, you know Eugene Garfield? Okay. He collected data from Science Citation Index. What was the data? I will give you the data. Using Science Citation Index. You know, on one side, he kept journals titles of what? The journals. On the other side, he took the number of research papers or articles and he analyzed that 20% of research papers are to be found in 20 journals titles. Okay. 43% of the research papers, whatever topic he must have taken into consideration, they were served by 100 journal titles. And 70% of the research papers have come from 500 titles of the journals. And total 100% of research papers have come from 2,200 journal articles. Okay, right? If you take out the percentage of this, you will find that it is 23% of the total number of journals. Am I right? If you take out simple percentage, how much percentage it will be for 500? It will be 23%. Do you look at this? Okay. What do you notice? What do you notice? What do you notice? What do you notice here? What do you notice? Okay. What do you notice? Yes. What do you notice here?
The ratio.
What do you notice here? That 70% of the research papers are published in 23% of the total journals. Almost 80-20 law. Do you understand? Do you understand? So, this is a sort of representation of Bradford's law, you know. And this is according to Pareto law. His name was Wilfredo Pareto. He was an Italian economist. The law he gave is Pareto. You see, they have been arranged in the order of, say, decreasing productivity. The representation is different. The representation of fact is different, but they have been put in the order of decreasing productivity. That is why number of journals are going on increasing. Am I right? Method of presentation is different. The equation of decreasing productivity is the same, which is according to the Bradford's law of scattering. That is why I am saying that Eugene Garfield showed the similarity between Bradford's distribution and the distribution of Pareto law. Okay? This is all about Bradford's law of scattering. Other laws we will take up later.